Right, so looking at exponentials. Again, a logarithm is an exponent. It took me forever to understand logarithms, and then all of a sudden, one day it just clicked. A logarithm is an exponent. So the rules we're going to look at here are going to be similar to rules with exponents. So we have the log base b of m equals to n. Well, this is your logarithm. Your logarithm is n. And if a logarithm is an exponent, then that means that that value is an exponent. So this implies that b raised to the n power is n. B raised to the n power is n. Now, there are some rules here. B must be greater than 0. But not equal to 1. Now think about what b is. B is the base. We read this as the log base b of m is n. It's not the log of b to the m. It's the log base b of m is n. Now, if b is the base, why do you think b cannot equal to 1?
Because
1 to any power is just 1.
1 to any power is just 1. So you would have infinite answers here for n. Now, m must be positive. And n can be anything. Positive, negative, fraction. Well, all of them can be fractions. And that's one other thing here. It's okay to have 1/2 here. You can have 1/2 to some power and get an answer. But it just can't be 1. So, if I want you to solve the log base 9 of 27, the first thing I'm going to do is set it up as an equation. I'm going to have the log base 9 of 27 equals to x. So then I have 9 to the x equals 27. I'm going to pause there for just a second. If 9 to the x is 27, well, what's 9 to the first power?
9.
What's 9 to the second power?
81.
81, right? So we jumped past, between 1 and 2, we jumped past 27. So a good thing to do here is to take this and rewrite it. So I'm going to say that 9 and 27 do have a common base. And remember, it's all about that base. Okay. That never gets old. So I'm going to rewrite this as 3 squared x equals 3 to the third power. Are y'all with me?
Okay. And then 2x equals 3.
Yeah. Well, once you have your bases alike, we get that 2x equals to 3, so x equals 3/2. So that would be the solution. 9 to the 3/2 power is 27. Now, there is another property of logarithms that's talking about the inverse. B to the x and the log base b of x are inverses. Now, we talked about inverses in here earlier, but it's been a while. What do you remember that we've said about inverses?
It's when x and y is y.
Yeah, that's how you come up with an inverse, yes. That's how we find an inverse. But if you take an inverse and you compose it, if you take a function, I'm sorry, and compose it with its inverse, you get
So 1
x.
X.
So if I have b raised to the log base b of x, or if I have the log base b, and then plug this in here, of b to the x, both of those will equal to x. Now, as we work through logarithm problems, what we're going to see is that this little trick is going to come in handy in solving some of the problems out. We use this a good bit in differential equations and calculus. So just know that going in.
Just forgot everything we learned in calculus.
Well, we didn't do differential equations, so you wouldn't have known that.
We should.
That's pretty much the beginning of Cal 2.
Oh, I'll be taking it.
All right.
We don't honestly don't really know that at all.
Say that again.
She said, what if we took Cal 2 instead of college algebra?
That would
We
be
had that
fun.
option. And I said we'd probably be better.
I wished we could,
Yeah. Really would be fun.
or I wished we could take both.
Yeah.
All three. No, I think I'll do it without C.
Or we can mix trig in it too.
All right, now let's think about what the graph of the log is. If you think about the exponential function, and I'm going to go with just 2 to the x. We talked about that last time in class. The graph of y equals 2 to the x, we said looked like this. It would intersect, well, it's going to curve up a little bit steeper than that. All right. And this was at the point 0, 1. Well, if you remember another thing about inverses of functions, what would be the inverse of this? The inverse of this would be the log base 2 of x. So this is the inverse. But if you remember, we said something about the inverses when we said that the inverses reflect about the line y equals x. So if I take this and I reflect this about the line y equals x, then I get this, and this would be the point 1, 0. Any question about that? So now, let's talk about y equals the log base 2 of x minus 1. Well, what's going to happen with that, do you think? What has this minus 1 here been doing to graphs throughout the semester? It's going to move to the right one time, yes. So I'd go through the point 2, 0 here, and this would be, and I would have a vertical asymptote here. And this would be y equals the log base 2 of x minus 1. So again, just a shift to the right. Now, it's a little bit harder to see this next one. Y equals the log base 2 of x and then minus 1. In other words, it's the log base 2 of x and then it's minus 1. But what would your instinct tell you you'd be having here?
Move down.
Yeah, you'd be shifting down 1. Well, here, let me try to squeeze it in here. Basically, everything between 0 and 1 would pretty much look the same until you got into right here. then it would cross at the point -1, 0. Oh, that's beautiful. You know, there's an art position open here next year. Hope I get it. Huh?
I didn't know.
Okay, yeah.
He's
So-
got it on you.
If they come in here and see this, I will not be teaching math next year. I'll be teaching art. So anyway, that's what we're looking at. Any question here? All right. Now, one last example. The domain. Remember what we also said. If you have a function in its inverse, and I'm going to take this away. I'm going to take these two graphs away and just talk about the parent function. What would be the domain what would be the domain of y equals 2 to the x?
Infinity.
Negative infinity to infinity, right? You can plug in any x value. What would be the domain of the log base 2 of x?
It should also be.
No, it'll be
Oh,
0.
0 to infinity, 0 not included.
Yes.
So if we think about this, the domain of y equals 2 to the x is negative infinity to infinity, right? And the domain of this is 0 to infinity. Now, we talked about this with inverses. The domain of one function is equal to the range of the other function. So the range of this log base 2 of x is
Negative infinity to infinity.
negative infinity to infinity. And the range of y equals 2 to the x would be what?
0 to infinity.
0 to infinity. Is there a question about that? So now let's go back to the one we did prior to this. Let's say we had y equals to the log base 2 of x minus 1. What would be the domain of that function?
Negative infinity to infinity. Wait. Minus 1 would be this.
All right, what does this minus 1 do to this function?
The move to the.
Move to the
Shifted it to the right one, didn't it?
1 to infinity.
So the domain here would be 1 to infinity. Now, if you're not confident with that, then you just have to say, well, I know that this value right here has to be greater than 0, so you could say, well, I know that x minus 1 must be greater than 0, which would imply that x must be greater than 1. And you could solve it out like that if you wanted to solve it out with an algebraic equation. So, that is all there is for 4.2. So y'all can go ahead and start on that homework assignment.
That was a quick one.